Hello everyone, welcome back to the channel. If you are preparing for top tech companies like Google, Amazon, Microsoft or any MAANG level companies, then computer network is one of the most important subject of you cannot ignore. So in this series I will be covering everything you need from basic concept like what is a network to advanced topic like how the internet works, DNS, HTTP, HTTPS, TCP IP, routing and real world system design concepts. So I will cover not just a theory, I will explain interview focus questions, real world examples and practical understanding so you can confidently answer in interviews. So whether you are beginner or revising before placements, this series will help you master computer network step by step. So let's get started. So basically I will cover basic of computer network. What is a computer network? LAN, MAN, WAN, topologies, OSI models, TCP IP model, OSI models, and another one is the physical data link layer. In physical data link layer we cover a transmission mode, switching, error detection, flow controls, MAC address or IP addresses, Ethernet basics, and network layer. Network layer we will cover IP addressing, routing, NAT. In a transport layer we will cover a TCP versus UDP, TCP features, UDP use cases. In the application layer we will learn the HTTP versus HTTPS, DNS, FTP, SMTP basics, cookies and sessions, and REST API basics. So and network security in for encryption we will learn the SSL, TLS, encryption basics, firewalls, VPN, common attacks, DDoS, main in the middle, phishing, and advanced topics for like CDN, video content delivery network for sending the video to server, load balancing, proxy versus reverse proxy, caching, web sockets we will use sending the APIs through server. Important interview questions is the explain OSI, what subnetting, explain what is a NAT. We will learn about the things, and coding plus CA computer network, implement how to prepare, and as well as. So we will start the what is a computer network. Computer network is a system two or more computers or devices are connected together to share data, resources and services. Like a computer network allows devices like computers, mobiles, servers and printers to communicate with each other using wired or wireless connections. Example, when you send a message or WhatsApp to one phone to another phone. When you open a website, like going to the website and write the something google.com. When you share files between computers. Key components, so devices, computers, phones and servers. Transmission medium, Wi-Fi, Bluetooth, cables, fiber optic cables. Protocols use the rules for communication like TCP IDP. TCP IDP used for three-way handshake. Network devices, router, switch, hub. Main purpose of computer network: data sharing, file messages, resource sharing, printers, internet, communication, email, video calls, centralized control servers. So types of networks: LAN, WAN, MAN, many type of networks, but these three are the main networks. Local LAN means local area network. Is use the small area like home, office. A wide area network we will use a large area like continental countries. And metropolitan area network is used in the cities. So first is a local area network. A LAN connects devices with a small geographic area like home. Examples: home Wi-Fi, network college lab, office network. Is the feature is local area network is high speed, covers small area, and is the user low cost, privately owned. Example: connecting your laptop, phone and printer through your router or Wi-Fi. Another one is a metropolitan area network. A MAN connects network across a city or large campus. Example like city-wide internet services, like is the Pune is the city, is the all network connects. City-wide internet services, cable TV networks, features medium speed, covers a city, more expensive than LAN. Examples: internet service provider connecting multiple areas in Pune. So wide area network means connects network over large geographic area like countries, continents. Example there, internet biggest when bank networks across countries, like use the Bitcoin to sending the data. Features covers large area, lower speed compared to LAN, expensive infrastructure. Example, accessing Google servers from your computers. So quick in the quick comparison table, LAN, MAN, and local area network, metropolitan area network, and wide area network. Features: area small, city in a LAN small, MAN city large. Speed high, medium, lower. Cost low, medium, high, and ownership private, semi-private, or public-private. So another one is the OSI models. So OSI models most important for MAANG, and topologies. And in the another 5 to 10 minutes after we will explain the OSI models. Firstly, we will explain a topologies: bus, star, ring, mesh. Bus topology means connecting to the all the data to single central cable, like all devices are connected to a single central cable. Features: simple and low cost, easy to install, data travels in one line. And disadvantages of bus topology means if backbone fails, whole network fails. Collision can happen. Example, old Ethernet networks. Star topology. Star topology means using all devices are connected to a central device. Only one device is the sending to data another device, like switch or hub. Features: easy to manage, failure of one device doesn't affect other, high performance. And disadvantages is if central devices fails, entire network stops. Example, modern Wi-Fi, office networks. Ring topology, devices are connected in a circular loop, like a ring structure. So features is the data travels in one direction or both in dual ring, no collisions. Disadvantage: if one node fails, entire network affected. Example, token ring networks, older systems. Mesh topologies, every device is connected, every other devices, like one computer connected to the another computer connect to the another computer. High reliable, features is a high reliable, no single point of failure, secure communication. Disadvantages: very expensive and complex setup. Example, military networks, high reliability systems. And is the quick comparison of topologies. Bus topology, single cable, and advantages: chief, backbone failure. Star topology use a central hub, ring circular, and mesh means fully connected, high reliable, and expensive, and more give the security. And another is the OSI model, open system interconnection. So in the OSI model, it is a 7-layer architecture used to understand how data travels from one device to another over a network. Each layer is a specific role in communication. So 7th layer of OSI model is application layer, presentation layer, session layer, transport layer, network layer, and data link layer, and physical layer. There is 7 layers in the OSI model. So first explain we will 7th, application layer, closest to the application layer means sending the data, email, or through website to another servers. Provide servers like web, email. Example, HTTP. HTTP means hypertext transfer protocol, FTP, SMTP. And say 6th is a presentation layer, converts data into readable format, like converts data into I will share WhatsApp any data, and data encrypt and decrypt, and sending the server to sending the another person in using a presentation layer. Encryption, decryption, compression, SSL and TLS, transport layer security is used the encryption and decryption. Session layer means manages the I will send the WhatsApp data to another person, so manages the time, start, maintain, and end. Keep connection alive. Example, login sessions, and sending the data to one person to another person. Transport layer is a very important layer in the OSI models. Ensures reliable data transfer. TCP, transfer control protocol, reliable. UDP, fast, no guarantee. In TCP we will use a web, and UDP is using the video calling or gaming latency for increasing latency of the time. So functions: error control, flow control. Network layer responsible for routing data finds best path. Example IP addresses, routers. Data link layer ensure error free transfer between nodes, MAC addresses, frames, device, switch. And physical layer sends raw data bits zeros and ones. Example cable, signals. So easy to remember all the OSI models. A means mnemonic, A means application, app store, apps TNDP, application, presentation, session, transport, network, data link, physical layer. In a real life example, sending a message in any person to send the message another person, like and a web develop in a web sending the data to server and get the data to server. So we will use a OSI 7 layers. So first layer is the application. You type a message, presentation, encrypt the data. You type a message like sending the web to server data, presentation encrypts the data, and session start the connection, transport break into packets, network find route, data link layer frames data, and physical sends bits. And TCP versus UDP. TCP versus UDP, transfer control protocol, and is the most asked question in interviews. TCP IP model, transmission control protocol, internet protocol. Is in the TCP IP model use the 4 layers: application layer, transport layer, internet layer, and network layer. Application layer we will use the user services, transport layer end-to-end communication, internet layer routing, and network access layer physical transmission layers. So detailed explanation of TCP IP model. So first is application layer, combines OSI applications. In OSI model we will 7 layers used, but TCP IP model only the 4 layers is used. Firstly application layer. In OSI models, application plus presentation and plus session. In your TCP IP only one application layer gives the functionality. Functions, user interaction, data formatting, encryption, protocols. We will send a hypertext transfer protocol, hypertext transfer protocol secure, FTP, SMTP, domain name system. And transport layer responsible for data delivery between devices, like TCP, reliable, slow but accurate, UDP, fast, no guarantee, functions, flow control, error control, segmentations. And internet layer responsible for logic addressing and routing. Protocols, IP, IPv4, IPv6. IP addresses is 2 types, IPv4 and IPv6. IPv4 is the old IP and IPv6 is the new IP. ICMP, address resolution protocol. Address resolution protocol is the user IP address to convert to address on MAC address. So functions, path selection, packet forwarding. Network access layers combines OSIs, data link layer plus physical layer. Functions, hardware addressing, MAC, data transmission, examples Ethernet or Wi-Fi. So OSI models versus TCP IP model. OSI models application, presentation, session. In these three, including only one give the TCP IP model application layer. We will use the transport layer for transport, network layer, internet, data link layer, network access, physical layer, network access. So key differences upon OSI models and TCP IP. In OSI models use 7 layers. In TCP IP model use only 4 layers. Theoretical model is the TCP IP use of practical model. Strict layer separation, flexible layer used for only learning and used in real world. So real life flow when you open a website. In a TCP IP model, applications use the HTTP request like hypertext transfer protocol. Transport, TCP connection, transfer control protocol. Internet, IP routing, network access data sent via Wi-Fi. So is the layer the differences. I will next topic, going to the next topic. Okay, transmission media. What is meant by transmission media? One person send to another person data. Transmission media is a path through which data travels from one devices to another devices. So types of transmission data: wired transmission data, and another is a wireless transmission data. So wire transmission data is a data travels through physical cables like twisted pair cables, coaxial cables, fiber optic cable. So twisted pair cable, two wires twisted together, used a LAN networks types UTP, unshielded and shielded, cheap, easy to install, and is the cheap, easy to install, less secure, more noisy. And coaxial cable, central conductor with insulation, used in cable TV, internet connection, better scheduling than twisted pair, bulky and costly. Fiber optic cable, we will use sending data to one continent to another continent. Uses light signal instead of electricity. Very high speed is the use of very high speed. Long distance like one continent to another continent, one country to another country. Like one person sending the data India to US is the sending the data sending the data like example. One person Instagram user sending the one reel to another USA person. So this cable sends the data to light signals in a very high speed, long distance and secure. But is the fiber optic cable is expensive. And wireless unguided media, data travels through air, no cables like Bluetooth, Wi-Fi. Types of wireless media, radio waves, use of Wi-Fi, Bluetooth, wide coverage, and interference possible is not happening. Microwaves used in satellite communication is the use the high speed. Infrared networks, short range communication, example TV remote. Satellite communication, use satellites in space, global coverage. Quick comparison, medium cables air speed higher, and fiber wired in a wired networks use cables wireless air higher higher speed, lower than fiber, more reliable, less reliable, installation cost high, setup easy, no mobility, high mobility. So another topic is the switching technique, circuit versus packets, very important. And bandwidth, latency, throughput. There is the terms are very important in networking interviews, are often confused. Here is a clear simple explanations: bandwidth, latency, throughput. So first is a bandwidth. Bandwidth is a maximum capacity of network. It tells how much data can transmitted per second. Like one person to share the any reel of another person to how to going to the taking the time is called as bandwidth. Measured in bps, bits per second, is the measure bits per second. Like you will watch a YouTube video we will share the any videos like one person to another person. Example, a 100 mbps connection can carry up to 100 million bits per second. Easy idea how wide is road is, and how wide the road is the many bandwidth in the use in the countries. Latency means delay in data transfer, time taken for data to go from one source to another source to destination, measured in milliseconds. Example, if a message takes 50 milliseconds, latency is 50 milliseconds. Easy idea is how long it takes a car to travel. Throughput, actual data transferred successfully. Real world performance is always bandwidth affected by network congestion, errors, hardware. Example, bandwidth is equal to 100 mbps and actual speed is 100 mbps. Throughput is the 60 mbps actual speed. How many cars actually reach the destination? In the quick comparison, bandwidth, latency, throughput, maximum capacity, delay, actual data transfer, unit bps, ms, bps, ideal time to share, high, low, high. And real life example is, imagine a highway. Bandwidth is number of lanes, latency is travel time, and throughput is the cars reaching destination. So is the next topic is the signals, analog versus digital is the two types of signal to send the data. Signals in computer networks, a signals is a form of energy used to transmit data from one device to another. So first signal is analog signal, a continuous signal that varies smoothly over time. Like analog signal smoothly over time, frequently sending the data, infinite values, not just a 0 and 1, represented as waves, more affected by noise. Example is a human voice, send human voice, give the command for chat gpt, give the prompt for chat gpt using the human voice. Radio signal shape smooth sine wave, and digital signal is a discrete signal with fixed value 0 and 1. Features like binary data, 0 and 1s only sending the data, less affected by noisy, easier to process and store. Example, one sending the data to through output computers. Internet data shape square waves. Key differences is the analog signals is the sending the data to continuous, and digital signal sending the data discrete method. Is sending the data infinite, 0 and 1. Noise is high, low. Accuracy is less or more. Uses old communication, modern system. So understand the easy trick is analog is natural, continuous, and digital is a binary and 0 1. And real life example is a talking on phone, voice is analog signal, and sending WhatsApp message data to digital signals. So ADC, analog to digital conversion, ADC, analog to digital, digital to analog. So another one is so it's will stop the video. Another topic we will cover the another videos.